Hello, let's continue our Sudoku adventure with Backscattering by Gene. Let's go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these arrows in the grid. These are called search 6 arrows. So let's say this arrow here, whatever digit goes in this arrow, say a 2, you look in the direction of the arrow, you count 1, 2, and you put the 6 there. So it counts how many cells away in that direction the 6 is. So if this was a 3, the 6 would end up here. If this was a 1, the 6 would end up here. Except we also have negators in the grid. These negate the value of whatever's in there, which really only matters for the arrows. But I'm going to use green for negators. Let's say this cell ends up being a negator cell. If this was a 1, it now goes backwards, like it's negative. So it goes in the opposite direction of the arrow if it's on a negator. So this would be a 6. And if this was 2, this would be a 6. All right, now how do we find the negators? Well, there's exactly 6 of them hidden within the Sudoku grid. Every row, every column, and every box has exactly one and only one negator cell. So if I put a negator cell here, I can't put another one in its box, in its row, or in its column. So none of these would be negator cells. And I'm going to use purple to represent that in my solve. All right. And in addition to that, this is very important to remember. I think this is very easy to forget. I have in the past, I've done like doublers and stuff in the past where I just completely forget this rule. Every digit from 1 to 6 is negated in one and only one negator cell. So if this ends up being, say, a negated 2, which would put a 6 there, and this was a negated cell, it's not allowed to be a 2. This violates the rule. So we have 1 to 6 once each within the negator cells. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, what catches my eye immediately is because whenever you look at search 6, you want to look for any arrows that are very, very restricted. So without the negators, this would need to be a 1 with a 6 here, and this would need to be a 1 with a 6 there because it's the only 6 it could look at. Obviously, that doesn't work, which means one of these two is negated, meaning the rest of this row is not. I'm going to use purple to represent that. One of these two is. And in addition to that, one of them is not, meaning it's going to be a 1, and it's going to be looking at a 6 either here or here, meaning these cannot be 6. In addition to that, one of them is negated, and so let's say this one was not. That's a 1, that's a 6. This cell here would be looking backwards towards the 6 and would be a 4. And I think it's symmetric the other way. So if this was a 1 with a 6 here, this would be a 4. So this is a 1-4 pair. These are not 6. These are 2, 3, 5. One of these is negated, and there's a 6 in one of these two. Okay. Now my eye is immediately drawn to this arrow here, which is now pointing at a not 6. So it has to be negated, meaning the rest of its row, column, and box are not, meaning this is negated. So we know this is the 4, this is the 1, this is the 6, and this is the other 2, 3, 5. We also know this is pointing down at a 6 down here, so it has to be 1, 2, 3, or 4. It cannot be a 1, though, so this is not a 6. All right, that's good progress. Oh, the rest of this column is also not negated. This also can't be pointing at a 6. Neither of these are 6, so this is negated, meaning the rest of the box, row, and column are purple, not negated. One of these two is, oh, this cannot be negated because it would be pointing off the grid automatically. So that's not, that is, these are not, and I guess we have to figure out if this goes forward or backwards. Okay, oh, right, we can't repeat in the negators. So this is not a 4. So it's either here or here. The 6 is in one of these two. How about this guy here? I mean, I'm not seeing a restriction yet. Oh, how about this one? This is not a 1, so this is only 2, 3. That makes a 2, 3 pair in our negators. So this, let's actually write that this is only 1, 5, because 2, 3, and 4 are used. So, what am I saying? Right, I wanted this one, and 2, 3 puts a 6 in one of these two. Okay, and that's going to affect this guy, because 3 away would put a 6 here, and that breaks the 6s here. So this has to be 2, and now that makes this 3, which makes that a 6, and it makes that a 6. Try to get this right. 2 away, 3 away. All right. And we're left with 1, 3, 5, no, 1, 5, 6 on our negators. 1, 5, 6. Oh, well, we know this is just a 1 and it's not negated. Okay. So these are from one. Oh, they're not 1. This one sees both of them. So this is our 1 and this is a 5, 6 pair. Ah, and that sees a 6, right? That can't be 6. That's 5. That's 6. That's not a 5. Oh, and this 6 is pointed by this guy. It's a 3. And I think it should just be Sudoku from here. I think every arrow has been satisfied. We have every negator with 1 through 6. Okay. No more variants, just Sudoku. What are we doing here? Let's just fill, oh, the 2 looks down, putting the 2 here. And then let's fill a 4, 5 pair here. Anything easy to look at? We need 3, 4, 5 here. These both can't be 3. Oh yeah, these 3s look up. That places this 3, placing 2 and 5. These are just 1, 3, 6. The 1, 6 looks up, putting a 3, and this is 1, 6. This digit is known, it's a 1. This is 4 or 5. The 5 says that's 4, that's 5, that's 4. These are 2 and 5. This is a 3. The 2 is not there, so that's 2 and that's 4. That's 5 and 4. That's 3. 1 and 5. This 5 says that's 1, that's 5, that's 6, that's 1. That's 4, that's 6, and we're done. All right, very smooth, Gene, especially for search 6 plus negators. That's difficult to to make easy. It adds a level of complication, but I'd say this was a very good difficulty. Yeah, I think probably really important was remembering that we couldn't repeat in our negator cells. Anyway, cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.